Welcome everybody. Lecture lab number 3. So this one we're going to focus on collections and data management. Collections are really key, really important. Obviously, data structures. Memory management has typically in the past thrown some people for a loop because it's quite a bit different than traditional memory management. After everybody's been reading about the new memory management scheme that Apple's coming up with, everybody's saying, hooray, we don't have to learn this new or this different way anymore. That's not entirely true. One, it's for iOS 5. So if you're supporting iOS 4 or 3, it's not going to be available to you. It's also probably not going to work perfectly right out of the gate, but much more importantly is the fact that understanding why it works and how it works is critical to having it work correctly and work smoothly and work efficiently. Because you can still rely on it, but your application can still not really take into account good memory management practices and still run into the same problems, same old problems that you had prior to ARC. And we'll talk about automatic reference counting later on, especially in the next lecture. But for now, we're going to focus on data collections and the traditional Objective-C and COCO memory management techniques. So we'll first start off with collections. The most simple collection is called an NS array. It basically keeps a list of objects. It's much like a vector in C++ and Java. It keeps the objects in order so that you can reference them by index, zero-based index. The next collection is a set. There's no particular order in a set, so it's more akin to a map, if you're familiar with that in C++ and Java. Map also, I believe. It's somewhat like a hash table. You can reference the objects within. I should actually go back here. An NS array, you can reference the objects, like I said, by index. Here are two examples of getting a hold of the first and the fourth object within the NS array. It's the collection name, the message is object and index, and then you pass in an integer, an NS integer, to get that object out. Zero-based, this is 0, that's object 3. And it'll return you back the objects that you've got in the NS array. All of the collections, by the way, have to be objects. They all have to have been subclassed off of NS object, or if they're your own class of object, they have to. There's some properties or some interfaces that you actually have to implement to use them with collections. So what that means is, and we'll talk about this in a few more slides, that native types in C and C++ don't go in these arrays. You have to actually put a wrapper around them, and that's actually not too hard to do. So as I said, sets, they don't keep objects in any particular order. The message for retrieving objects is the collection name. In this case, the collection we're just calling set. Contains object is the message. The object that you're looking for is the parameter, and this message returns back a Boolean value, yes or no. This is much faster, obviously, than searching through an array. This is O of n. This is in constant time. It's usually done with a hash table underneath, or a map, or a multi-map underneath. NS counted sets are the same as sets, except that you can have duplicate versions of your objects contained within that set. In an NS set, you can't have duplicate objects. In a NS counted set, you can have duplicate objects. That allows you to also use a new message called count for object, which takes you start with the collection name, count for object is the message, you pass the object in that you're looking for, and it'll give you the number that are in there. Also much faster than using an NS array. An NS dictionary this is a really key critical component of COCO. Much of the attributes that you want to set for various objects, and you'll be doing much more of this later on, but many attribute tables are set with NS dictionaries. NS dictionaries are just like hash tables. You basically have a key and a value pair, or KV pair. In this case, what we're doing is we've got an NS dictionary already set up. Our keys are the objects on the left, so we've got a blue square and a gray square are our keys. The values that are associated with those keys are pointed to by the arrows, the green square and the red square. Here's how you get a hold of values from your key. It's your dictionary name or the collection. Object for key is the message, and then you pass in your key object. The keys can also be sets, can also be dictionaries. So you're not limited to the types of objects that you're looking for, but they do have to be objects. Your keys do have to be objects. So there again, you can't use native types, native C types and C++ types, but you can wrap them, and we'll show you how to do that in a slide here or two. So here's an example. Let's say we've got the value in our dictionary is the actual text for the definition of COCO. That's our value. Our key is an NS string. The NS string is COCO. So to look up this value in the dictionary is collection name, dictionary, object for key, and then our key is an NS string constant at COCO. Does that make sense? Questions? Okay. So underneath the hood, to be super efficient, collections are by default immutable. So you create collections once, you have access to them, and you can get the objects out of them very quickly because there's a lot of optimizations, and you know this from 61B and 61C. There's a lot of there's a lot of optimizations that you can do under the hood if you don't allow the collections to be mutable. However, if you need to have a mutable collection, they are created with the keyword here is mutable in front of the name of the collection that you're trying to create. So, for example, if you need a mutable set, it's NS mutable set. If you need a mutable dictionary, it's NS mutable dictionary, and so on. You can convert in a mutable collection into a mutable one if you need to modify it later, but since you're not allowed to modify the mutable one, you actually make a copy of it that you can then mutate and change. To make that change, every collection has got a method called mutable copy that returns back a copy, obviously returns back a copy of itself, except as a mutable collection. Clear? So there's additional methods. Obviously, once you have a mutable collection, there's new methods that you can use. Now you can add objects to your collection. So let's say we've got an array that we want to append an item to. It's the name of your collection. We're going to call it array here. Add object, and then the object that we want to add. Let's say for a dictionary, if you have an NS mutable dictionary, it's set object and the object that's going to the value and then the key. So once again, dictionary, set object and the object value, for key and the object key. There's a ton of documentation about every one of these classes inside of that you can access through Xcode. You can access it externally too. You can Google a lot of these things as well. but inside Xcode, you can find a ton of documentation on these collections. So if you want to see all of the additional methods that you have for mutable collections, or if you want to check to make sure that your collection can handle some functionality that you need, like fast lookup or fast removal of items for mutable collections, there's a ton of documentation on it. So, accessing every element in a collection is a really common thing to do. In C++, in the STL libraries, you see that iterators are prolific. They were initially created this way in Objective-C as separate classes. The class was an NS enumerator, then the variable, and then when you passed it your collection, or when you gave it your collection and passed it an object enumerator, it was to return you back an NS enumerator pointer that you could then step your way through your collection with. So let's say we've got a collection that's full of objects, then the correct way to step through it was enumerator next object would give you an object back, the next object in your collection, whether you were using a set or a dictionary or any of the collections. If it returned you back a nil, you were done. Otherwise, you could use the object that was returned. Say if you were going through and you were going through a whole bunch of NS color objects that you had in a set, you could pull each one of them out one at a time and say display them until you ran into a null. This is the verbose, slow, older way to do that in Objective-C 2, I believe.
Right. The new way to do this came out in 10.10.5.
Okay, so in OS 10.5 they give you a new way to do this, a new shorthand way to do this. You may recognize this. This is a lot like Java's shorthand. So for and the type of the object that's in your collection, the variable name in, and then the name of your collection. This will iterate through every single object that you've got inside your collection, obviously, and set the object variable to be that item. And you can do whatever you want with that object, and it'll iterate through correctly, just like the old enumerator, until it reaches the end of your collection, and then you're done. So, old syntax, NS enumerator, you may still see this in older code, especially code that came out before 10.5. The new way, you'll see for object type, the name of the variable, in, and then the name of your collection. Questions so far? Pretty clear? Okay. So, some people think, oh, well, I need to add some more stuff to my collection. I need to add something that gets every other item in my collection. So I should obviously subclass collections and start adding functionality to it. You don't want to do that. Trust me. Implementing a subclass of these collections is a pain. It's a real pain because there's a lot of methods that you actually have to implement within your subclass to be considered a correct collection. So the obvious way to do this, just have your class include an instance variable of that collection type, and then you can add your methods to it, add whatever methods you need to modify this whatever your collection is. In this case, we've got an array that has an NS array that has the NS array within it, as opposed to trying to subclass the NS array, and we access the instance variable instead of trying to subclass and handle all of the methods. If you want to do this, go for it. It's an interesting exercise. There's a ton of documentation on it, but it's not a trivial thing to do. It's the best way to do it.
Apple in documentation for these classes says not to do it. And it's worth noting, this is another case where a category might make sense if you just want to tack on one method to a class.